Let's go ahead and modify the robot firmware that you are working with and flash to the robot. So we're going to change the firmware so the robot behaves differently, and you can make a lot of different modifications depending on what you want. Now, I'm working in the build IDE, and the language that we're working in is a language called C++. Now, not everything you see on the screen is going to be in C++. For example, any text that's in green, for example, the section that I've highlighted that has this // in front of it, these are what are known as comments. These are not in C++, but basically it tells the build IDE to ignore all of the text after the // because these are actually English comments for us as programmers. In addition, you'll also see this other style of commented text, which has /* and everything in between the opening /* and the closing */ is ignored. And this is another style of comments that allows me to break up the program into different sections to make it more readable. Now, everything else, however, for example, this pink and blue text and all of this white text, that is in the C++ programming language, and that's what we're going to be working with. So when you're writing computer programs, they are a little bit finicky in the sense that you have to type everything and it has to follow a set of syntax rules. It's not like English where if you punctuate something incorrectly, or you use bad grammar, people will still understand what you're saying. C++ is a programming language, and programming languages are very restrictive in terms of how you capitalize, punctuate, and space things out. Now, the sections that we're going to modify are down here at the bottom. So there is one section called void setup. This void setup section, that's what we call the setup function. This contains code inside of these curly braces that's run when you power up the robot. Every time you power up the robot, it's going to run this code. If we scroll down to where it says void loop, this is run continuously after the robot's powered up. So after the setup function runs, it's going to run all of the code inside of here. And you'll notice that there's a lot of different functions that are inside of here. We have forward, and notice that these are two parentheses, an opening and a closing parentheses, and then a semicolon, and then a delay with a number inside of it. So the first modification you can try is to modify the number inside of the delay. Frequently, a lot of things in programming are given a name that has some sort of meaning that you should be able to figure out from the name. So for example, if I try changing this to 500, and then saving the firmware, I can change the delay, or how long it's going to wait after it tells the motors to start spinning forward. After I make a modification, every time I make a modification, I'm going to go ahead and hit this verify button. The reason why I do that is because it's going to take my C++ code, it's going to compile it or translate it into a firmware binary. In other words, a file that contains the instructions in a format that the particle photon board actually understands. And then if it works, I can go ahead and flash it to see what happens to the robot after I make those changes. If I was to make a mistake, like for example, I forgot to put a number inside a delay, and I hit the verify button, you'll notice that an error happens. And the errors aren't particularly readable. And that's because C++ errors are designed for programmers by programmers. And it's easiest just to try something, and then if it doesn't work, you can just hit undo. And make sure that you do hit the verify button after every change that you make. Now, in addition to modifying the numbers inside of the delays, I can try other things, like adding additional code. Maybe I don't want the robot to just go forward, spin left, and spin right, but after that, I want it to go forward. And once again, I'm going to compile it. And then after it goes forward, I'll wait a full second, and then turn right, and then delay a half second, and verify that as well. Just to see what happens after I make those modifications, I can go ahead and flash the firmware to the robot. It will automatically update wirelessly, and then the robot will go ahead and reboot. It'll run the setup method, and then run the loop over and over and over again. So those are some modifications that you can make to the main robot loop, and try some different things and see if you can, get your robot to dance.